Oops. Can everyone hear me? Okay. So today and Wednesday we will review, and then Friday there's an exam over chapters 3 and 6. So on As You Learn, it shows exam Friday, October 22nd, and then the next one is November 12th, and your final is December 3rd from 2 to 4:30. The exam this week, there'll be part take home and part in class. Any questions so far? Wanted to pull the
I have a
chat up.
question.
Go ahead.
When will the take home be available?
The take home tonight. I just
Okay,
wanted to
thank you.
take it first. You're welcome. So the take home should be up tonight. There's 7 questions on the in-class portion, and there's 6 on the take home. I think, as long as I look the right one up. For some reason, I thought there was 7 on both. Yeah, that was the right one. So this is the take home. This one's kind of 3 problems, but so I'll put this up onto Blackboard today on As You Learn. Any questions? The outline is on As You Learn. Oops. If you go to weekly checklist, and we are now in week 10, it's in here. And it looks like this. I'd look at your group assignments, both of them, and the homework on my math labs. And these numbers here, these are all my math lab numbers. Section 3.1 and 2, 3.3, 3.4. So those correspond with your My Math Labs. Even if you got them all right, you could go back, say you want to try this one again. You go back to section 3.3, go on number 3 and say try another. If you mess up, it won't lower your grade. But if it's one you missed and you do it right, it will improve your grade. And we'll probably cover chapter 3 today and then 6 next class. But these are all the things that are on there. You want to make sure you know how to find a quadratic, max and min, equilibrium, price and quantity, and break even. Profit is revenue minus cost. I think I have that written somewhere else too. Piecewise functions. I think there's only one, but there's a piecewise function. That's the one we did. One of them's postage, because when you go to mail something, it stays at a certain weight at a certain price, and then when you go over that weight, there's another price, and it stays at that price until you hit another one. And that's why the stamps are certain amounts. Linear, quadratic, and power function, there's one problem. That first one you saw on the take home, where you have to find, just like the lab. Well, it's not, I think the lab was a little more difficult because it asked more questions. But you'll be given data and you'll have to find the linear, and it's r squared, the quadratic and the r squared, and the power function. And then whichever one is r squared is closest to 1 is the best fit. And then using the best fit, you'll have an estimate. But we'll do an example today. So there's one of these. There's lots of limits on both tests, the in-class and the take-home. Finding the limit from the left and the right, whether it's a graph or an equation. What else? Where it's discontinuous. And remember, this is where we did the average of a function. When you take the average of a function, you divide it by x or multiply by 1 over x. And there's a problem that we'll do in my math lab, and that's chapter 6. Also, chapter 6 was rates of change. When it's the rate of change between two values, that's the slope. F of b minus f of a over b minus a. Instantaneous rate of change, you can use the limit as b approaches a of f of b minus f of a over b minus a. Or you can use the definition of the derivative, which is the limit as h approaches 0 of f of x plus h minus f of x over h. And on the take home, there are 3 problems like this where you have to use this. So that's 3 of them. Because the next chapter, we're going to learn the short version. So I just want to make sure you understand it, because after this test, we'll never do the long version again. Derivative is also called marginal. So marginal profit, revenue, and cost means the definition of the derivative. Or you can use this one, either one of these. And I rewrote the profit formula because it kind of goes with revenue. Revenue is your price times your quantity. And quantity is X unless it states otherwise, but for this test, it's just X. Any questions so far? I didn't see the practice problem on my math lab. I don't know if I accidentally skimmed over it or if it was in a chapter before using the formula. But so I made one. But this should say revenue, not profit. We want to find the maximum revenue when however many motorcycles are sold and what price we sell them for. I guess since this one's here, we'll start with this and then we'll go to the beginning of chapter 3. But is there any questions before we start? Has anyone already looked over the review and has certain questions on certain problems? Okay, so we'll just start this and go right in order. So for this one, we know that, and this would not be given. Oh, formula sheet. You can have a formula sheet if you want. So if you want to make a formula sheet of everything, you can. Because if I tell you you have to memorize them all, then you're going to put little sticky notes all over your computer with all the formulas. So you can have a formula sheet. This is the formula. The demand price for a motorcycle is P equals 21,000. And it said this was the price. Price is a lowercase p, profit is a capital P, where X is the number of motorcycles. And P is the price. P is price. Find the revenue function. Revenue is price that you sell it for times the quantity, which in this case the quantity is X. The price we sell it for, 21,000 minus 7X times X. And then we just need to distribute. So our profit function is 21,000x minus 7x squared. Any questions on that part? I keep putting profit for some reason. This is revenue. So this is the revenue when X motorcycles are produced and sold. It wants us to find maximum revenue, how many motorcycles need to be sold, and the price we would sell them for. Well, if we look at the function, notice it's quadratic because it's x squared, which means it's a parabola. Because the x squared term is negative, this parabola is going down. So there would be a max. The vertex is the max. Well, to find the vertex, remember the x value is negative b over 2a. Make that part. But the vertex is negative b over 2a. A is with the x squared term, b is the x, and c is the constant. So in this problem, a is the negative 7 because it's with the x squared. B is the 2100, and C would be 0. Negative 21,000 over 2 times A, which was a negative 7. And you should get 1,500. Any questions on that part? Now think about what X means. X is the number of motorcycles. So 1,500 motorcycles. Now I need the price I sell them for and the revenue. Revenue, use the revenue equation. If we use this equation in place of X, we put the 1,500. So we're going to sell 15,000 motorcycles and we'll make a maximum revenue of $15,750,000. So our revenue is the 15 million. When 1,500 motorcycles are sold for a price of, we have to find the price. Well, price, we had a price equation right here. So we can plug our 1,500 in for our X. So we'll sell our motorcycles for $10,500 each. We will sell 1,500 motorcycles and make a revenue of $15,750,000. You'll definitely see this on the in-class exam. Any questions on it? Three 3.1. Now these problems here, I printed the problems from my math lab. And so from 3.1 and 3.2, you want to make sure you know 8 and 9. Now the other stuff will help you also, but 8 and 9, you'll definitely see ones like it. And number 8. For number 8, it says, the total revenue function, this is on the in-class one also. The total revenue function for a product is given by R equals 345X in dollars. And the total cost function for the same product, C equals 4,500 plus 30X plus X squared, also in dollars. The input X is the number of units produced and sold. So they give us the revenue and the cost, and X is the number of units sold, and we are in dollars. Part A. Form the profit function for this product from the two given functions. Well, we know profit is revenue minus cost. Our revenue is the 345X minus our cost. And what you need to be careful of, this is the most common mistake with this problem. You're not just subtracting the 4,500, you're subtracting this whole thing. That negative has to distribute to all of the cost. So it will change the sign on the entire cost function. Be careful of that. Now you don't have to rewrite it. You can make this a plus and then change your signs. Any questions so far? So P of X equals, I'm going to put it in decreasing order so the X squared goes first. We have a negative X squared. And then we have two X terms, so we can combine them. 345 minus 30 is a positive 315X. So I combined those two. And then the constant, negative 4,500. So that would be part A. Now notice they're asking two questions that are the same. What's the profit when 9 units are sold and produced and sold, and what's the profit when 24 are? When you have more than one to plug in, you can still plug it in. You could go for 9. Negative 9 squared plus 3, 15 times 9 minus 4,500. And you could do it that way. Or you could plug your equation in here. Negative x squared plus 315x minus 4,500. And then you don't have to graph it. You just go to your table, second and table, and you plug in your 9, and the other one was 24, and it gives you the values. So the 9 was a negative 1746, and P of 24 is 2484. Now, of course, you're supposed to show your work. So you could write it like this, or you could put using TI-84 table. That way I know you didn't just get the answer from somebody else who a private messaged you. So just put from using table, and that's fine. But any questions on that? So if you have more than one, you have to plug in. Now notice when we plug in 9, we have a negative value. Well, that's because we haven't broke even yet. So we haven't sold enough to cover all our cost. But at the 24 we have. Any questions on that? Part D. How many units must be sold to break even? Well, to break even, that is when revenue equals cost, or you can just set profit equal to 0. Now, if we set the revenue equal to cost, because this is x squared, we've got to subtract 345x over. So I might as well use my profit. So I would set profit equal to 0. Negative x squared plus 315x minus 4,500 equals 0. Any questions on that? Does it say what to round to? It doesn't. Any questions so far, though? You could try and factor this, but I would use the quadratic formula. So another formula, if you don't have it memorized, you might want to put it on your sheet. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. The a is the negative 1, b is 315, and c is the negative 4,500. Any questions so far? Negative 315 plus or minus the square root 315 squared minus 4 times A times C. A is -1, -4, 5. Huh. All over 2 times A. I was thinking this was positive, but it's not. Calculate inside the radical first. And we get 81,225. This is a perfect square root. It's 285. So we have -315 plus 285 over the -2, and -315 minus the 285 over 2. You're going to enter it all at once, put it in parentheses. So the first one, I put a parenthesis, -315 plus 285 divided by a -2. It is a negative. I hit enter. I got 15. For the other one, hit second and enter. If you hit second and enter, it brings it back up, and then you just make your plus sign a minus sign. Minus and hit enter. 300. So it's 15 and 300. Both of those are where we break even. Now, the difference between them is our cost is a parabola going up, and revenue is a straight line because it's x to the first. And so these are our two break-even points. The lower one, 15, is where you start making money because this is the revenue. And then the higher one, the 300, is where you start losing money because the cost is higher, where you need that new system to come out. But is there any questions on that? Positive. I think we also found this on Desmos. If you wanted to use Desmos, you could. If we went to if we put our revenue, which was 345x, and the other one was 4,500 plus 30x plus x squared. that? Oh, I forgot the y equals. You need to put y equals on this. I'm so used to the TI-84, you don't need it. Still not put. Why isn't it putting? What's our answers? 15 and 300. Hmm. I don't know why it's not showing it. There we go. Yeah, this one, the numbers are just so big that it's not. It's not a good one to use this, but you could use it. It's just not, this one's not. But it would be where the two intersect. Any questions? If you do want to do it using Desmos, let me know and I'll record a smaller value so they look better. But I like the quadratic formula. Any questions on that one? But it should have shown this, but it's the y values are too high. Any questions? Number 9. This is also on the test. Suppose that the demand and supply for artificial Christmas trees is given by the functions below, where P is the price of tree in dollars and Q is the quantity of trees that are demanded and supplied in hundreds. So this is in hundreds. Quantities in hundreds. Price of tree. Okay, so price is dollars. So this is our demand, and this is trees in hundreds. And P equals 0.01 Q squared plus 5.91. And it'll be the same quantity of trees in hundreds, and this is in dollars, and this is the supply. Find the price that gives the market equilibrium and the number of trees that will be sold or bought at this price. Equilibrium is when the supply equals the demand. So you set the two equal. So we set them equal to each other and solve. Again, we have a quadratic, so we need to get it set equal to 0 by bringing these two to the other side. We have our 0.01 q squared. When we bring this over, it becomes a positive 0.1 q. Then when we bring this over, we're subtracting it from the 5.91. Okay. So when we subtract these, we should get a negative 103.79. Any questions on that? Using the quadratic formula, negative 0.1 plus or minus the square root of 0.1 squared minus 4 times 0.01 times a negative 103.79. So negative b plus or minus b squared minus 4ac all over 2 times a. Any questions? Doing underneath the radical, we have 0.1 squared plus 4.1616. And I think that has a perfect square root. Yeah. The square root of this is 204. We have a negative 0.1 plus 2.04 divided by 0.02 and negative 0.1 minus 2.04 over 0.02. Typing in this one, I put parentheses negative 0.1 plus 2.04 divided by the 0.02 gives us 97. And then we go second and enter, and we change in front of the 2, we make it a subtraction. And we get a negative 107. Well, a negative amount of Christmas trees doesn't make sense. So it's the positive 9,700 trees. So to find the equilibrium quantity, because this was our Q, it would be 9,700 trees. To find the price, you can plug into either one. You'll get the same answer. I'm going to use the first one. 109.70 minus 0.10 times 97. So if we sell the trees for $100 each, we'll sell 9,700 trees. An equilibrium is where what you're selling and what you're producing are the same. So this is the amount you need to sell them for, and you'll sell all of them, all 9,700. If you go too high, then you won't sell enough. If you go too low, then you won't have enough for the demand. Any questions on that? Positive. So from that first homework assignment, 3, 1, and 2, number 8 and 9. Section 3.3 on my labs. I chose number 3 or 4. Either one of these would be good. I don't know why I chose 3, but for the non-extreme weather months, a company charges $5.10 plus, and notice that this is in dollars and this is in cents. So you have to be careful and change your units. Per kilowatt hour for customers using up to 1,200 kilowatt hours. And then they charge 62.064 plus. Again, this is in cents, so we'll have to change it to dollars per kilowatt hour above 1,200. So you only pay this extra change on the amount that's over the 1,200 for customers using more than 1,200 kilowatt hours. So first of all, we know this first one, 510 plus, we need to make this into dollars. So 4.747 would be 0.04. Because it's almost 5 cents. This would be 5 cents. So this is cents, and this is dollars. Which then means this first one's wrong because this is dollars and this is change or cents. So we know it's not this one. Go to the next one. 510 plus, they changed it, so that's correct. But notice it says X is greater than or equal to 1,200. But this said for customers using up to 1,200. So this part's wrong on this one. So then we go to the next one. $5.10 plus, they changed that to dollars, and it's less than or equal to 1,200. So this could be right. Notice the next one's identical, so it could be either one of these. Now you can see I marked this one already from my last class. But the reason that it's the bottom one and not this one is because of what it says right here. It's this 3.788 cents per kilowatt hour above 1,200. So you're not paying for all the kilowatt hours. You're only paying for the ones above 1,200. So you have to take that 1,200 off. And that's why it's this one and not this one. This one you're paying the total kilowatt hours. This one you're only paying what's over 1,200. So it would be this one. Any questions on that? What is the monthly charge if 990 kilowatt hours are used? Well, for 990 kilowatt hours, and we're using this bottom one, that would be this one because it's less than the 1,200, where this one's over 1,200. So it would use this formula, and then we plug in the 990. 5.10 plus 0.04747 times the 990. So it would cost $52.10. Any questions on that? The other one, 1,510 kilowatt hours, that's over 1,200. So we would use this formula. $62.064 plus 0.03788, 1510 minus 1,200. And that comes to 73.8068 or 73.81. Any questions on that? Any questions? From section 3.4, there's one like number 1 or similar to the group assignment in chapter 3, where you have to put in your data, and you can put it in Excel or the TI-84, it's up to you. So what I did was I went under Stat and Edit, and I typed in the X values and the Y values. So 1 through 6, and then 3, 9, 16, 25, 36, and 49. Now this is on the take-home part. So on there, though, you'll have to find all 3, not just 2 like this one. You'll find the power function, the linear, and the quadratic. Now to find them, second and quit, they are under Stat and over 1 Calc. There's the linear, there's the quadratic, and then the power function's further down. So we'll do the linear first. Linear, go down to Calculate. And there it is. So this is my A, 9.143. Linear is this one. 9.143x, and then B is minus 9. And the R squared, 0.97915. The closer R squared is to 1, the more accurate it is. So that's pretty strong. To do the power function, Stat over to Calc, down till you see power, which is right there. Hit enter. Now, if you have the TI-83, once you hit enter, it automatically does it. Calculate. A times x, and then that caret means b is in the exponent. So if we look at this one, 3.004 x, and then this is our exponent, 1.545, because it said 3 decimal places. And the R squared is really strong, 0.99954. And I would tell you if I don't tell you how many decimal places, go enough so that you can see if they're different. Like this one, I needed to go more than 3 to see. So this one is stronger than this one. And then when we do the quadratic, you can see this one's even stronger. They're all good, but this one's closest to 1. To find this one, second and quit, and then go down to stat, calc, and quad, which is the 5th one. Notice it says ax squared plus bx plus c. So a 0.911 x squared plus 2.768x minus a half. And the r squared. So this r squared is the closest to 1, which means it's the best fit. Any questions on that? Now I did put, just like the lab, whichever is the best fit, find, in this case I put f of 10. Well, this one's the closest to 1, so this is the best fit. So you want to plug 10 in here. So 0.911 times 10 squared plus 2.768 times 10 minus 0.5. You get the 118.28. When you're deciding if it's extrapolation or interpolation, you look at your x values. Our x values go from 1 to 6. 10 is not in 1 to 6, so it's extrapolation. If these went from 1 to 20, 10 is inside there, then it would be interpolation. So it's extrapolation because this only goes 1 to 6. Any questions on that? That's everything from chapter 3. Any questions?